Hola, macarones. I was just helping somebody out with 39 and 9-1.
I have more questions for 9-2 if nobody else has any questions right now.
Yeah, you can be their hero.
Okay, I'm going to be their hero. So for 9-2, number 15.
Yeah. 15?
Yes.
Okay.
I'm not entirely sure how to set that up.
So this is one of those. All right, wait a minute. I got a chat. Okay, I'll do that in a minute. You need to memorize. So basically, I would highly recommend you memorize sine of pi over 2 minus theta and cosine of pi over 2 minus theta. Because once you know those, that means that you know tangent of that mess and cosecant of that mess and so forth. So these are on that sheet. Oh, shit, that I can't access at the moment. Wait a minute. There I go. All right, this is just going to sit here. Anyway, it's on that sheet, right?
Okay.
So you got to know the little, I mean, obviously you should know what sine of pi over 2 minus theta is. It's shifting sine by pi over 2. What do you get when you shift sine by pi over 2? See here? You get cosine, of course. So you got all these guys. But if you just memorize these first two, then you automatically know the other ones. Or you can memorize them all. It's up to you.
Okay.
But remember,
I was thinking it was an angle identity.
Oh, no.
That's why I was like, I don't know how to set this one up. Okay. That actually explains a lot.
Yeah, we don't have that for these. So yeah,
right.
Good point. Yeah.
Okay.
So
Thank
no,
you.
thankfully no. You're welcome. Anybody else have anything? Let me see. All right. I'm only down 20 people or so. Oh yeah, I'm sorry. I do have one other one in section 9.3, number 12. Yeah. So, all right. I really like this one a lot. I have no idea how you guys feel about it. So, one thing I need you to realize, let me spotlight me because it's all about me. All right. Let me remind you about a couple things. So we know that sine 2 theta. Oh, let me try to start writing over again. Hold on. Sine of twice an angle is 2 sine of that angle cosine of that angle. Okay. So what if I multiply both sides by 2? Don't I get 2 sine twice of an angle equals 4? Okay, that's all I need to write. That should be all I need to write to help you with number 12. Is that all right? Or don't take me at my word there. If it's not okay still, then let me know. I don't mean to say that like to stifle any more discussion. Yeah, because now I know that the theta I'm talking about is pi over 8. So now I can replace theta with pi over 8. Yeah, exactly. And that's as much as I'll do. You got it. That's the immediate usefulness of the, so you got proving identities, which is one whole thing, but then you got the usefulness of the identities, which this is sort of a part of that. Oh, I see. Yeah. Yeah. I'm trying to be better about, I'm not going to put any more detail than I currently am on the videos. Yeah. Good point. Okay. Anything else, guys? I think we looked at number 11 at some point back in the day, but that's what you're saying. You didn't know which video it would be on. All right. All right, so I'm going to stop sharing. So first thing I want to show you is, this is a very strange, this was fantastic. I spent, so let me show you this. Just to make, just so you know what's happening next here. Hold on. Where'd you guys go? There you are. So I was working on updating, getting the part 3 of the homework sheet out. Don't look at all this shit. This is all from, I just copied and pasted and whatever. And I had figured out most of this homework. And then the next morning it was, my save file wasn't there. So I was like really upset about it. Anyway, so at least I want to show you, I got to go redo all this shit. I at least want to show you, my current plan is to have still this Thursday to have a quiz on 9.1 through 9.4. I wanted to see, it feels like to me, sounds like I'm going to start singing a song. I wanted to see, it feels like to me, a part of my world. Maybe I want to move this to the 9th.
Yes, please.
Especially considering how few chapter 9 homeworks I'm getting. All right.
The struggle is real for chapter 9.
Yeah, and that's why you can you can ask questions like you were. All right. You guys are too excited about that, so I don't think I'll do that. I'm joking. It was a funny thing I said. So we'll make that official. We'll make that on the 9th. And then I got to figure out the rest of this. So the most important thing is the next quiz, 9.1 through 9.4, will be a week from today. All right, let me see. I'm getting more people. Oh, shit. I can't access chat like this. All right. Yeah, whatever. Yeah, don't try to congratulate me too much on that. All right. Anything else from homework stuff, guys? Or I just want to make sure before I jump into some new stuff, or not new stuff. All right. So we need to prove. So last time, just to remind you guys, I'm going to remind you what we did at the end of class last time. Oh, can I do a half angle problem? Sure. Do you have one in mind, or what kind of half angle problem are you talking about? Let me see. Or do you have one in mind, or because there's many different types. Let me show you. So you got this here, right? Find the exact value using half angle formulas. Are you talking about a problem like this? Yeah, okay. All right, okay. So first off, do you remember what the half angle formulas are? So these are some that you have to memorize. So you need to know what sine of theta over 2 is. Like 17. Oh, okay. 17 is interesting because, let me show you. Oh, wait a minute. Everybody's chatting at me now. Sure. Yeah, in a minute. Hold on. That the tangent half angle ones, the tangent half angle, you don't have to memorize. So if I ask you a question about that, I'll put the formula on there. Otherwise, it's just using the formula directly. So for example, we got this here, right? Let me see if I can remember that. Let's see if I can do it. So you got tangent of 5 pi over 12. Do you see how that's half? What is 5 pi over 12 half of? No idea what I'm talking like that. I am part Georgia boy. When I go back home, I get my Georgia thing going on. Hey guys, how you doing? So what's 5 pi over 12 half of? Anybody? What's 4 half of? Go ahead. Sorry. Yeah, 5 pi over 6. I love it. Right. And I know that, let me see if I can remember this. Was it 1 minus cosine over 1 plus cosine? Is that what it was? I don't remember. I told you I wouldn't make you memorize anything I don't have memorized. I don't have these memorized. And I did it. Yay. Look at Jeff go. All right. Are you with me out there? Private chatter? Or are you private chatter? Yes, you are. Yes. Okay. And now it's just plug and chug shit, right? So what is theta? Theta is 5 pi over 6. Do you see that? So once you identify what this is half of, that's what theta is. And you know what, sorry, you know what love is. No, you know what the cosine of 5 pi over 6 is, right? And it shows up twice. That's beautiful. Is that all right? Do you guys? That's the power of the identity directly, is it enables me to calculate trig functions of angles that I don't have directly memorized because they are related to angles I do have memorized. Okay, I like it. So even as you're doing the homework, it's okay to have that trig law sheet sitting next to you. Just for the ones you're supposed to have memorized, try to write the formula out and then check it. Try to get it in that old brain of yours. All right. Let me see. How's that? Anything else before I jump back into things? All right. Oh, wait, I missed something earlier. 48 and 9-2. Okay. 48 and 9-2. Shit. What are you doing to me? Oh, okay. I love you guys. So do you see how it's got the tangent, sum, and difference? Oops, sorry. So here's the tangent, sum, and difference, right? And you just rewrite the top, rewrite the bottom, and keep on going. Yeah, you could do that too. Good point. That actually, I think, would be better. So the suggestion I'm getting is you rewrite this as sine of a plus b over cosine a plus b. Is that what you did? Over sine of a minus b over cosine of a minus b. Yeah, I like it. Now notice that this is sine of a plus b over cosine of a plus b times cosine of a minus b over sine of a minus b. Does anyone think I'm insane? How did I go from here to there? Because division of a fraction is multiplication by the reciprocal. Bam! And that looks like it will be very useful, maybe. I don't know. Did you just say, yes, I did that? Or is that something new you didn't try? You did this already? Shit. Oh, so, and the reason this looks like it might be good is because sine a plus b, I mean, look at the result. So always keep in mind the result, what I want to have at the end. So this would be sine a, sine, cosine b plus sine b cosine a all over cosine a cosine b. I don't know if I really want to do all this. Can you guys tell? I mean, it really is just, oh shit, what did I just do? Cosine's not that big of an asshole. All right. Cosine a cosine b plus sine a sine b all over sine a cosine b minus cosine a sine b. I don't know if that's going to go anywhere. That looks pretty gross. That looks pretty gross. Yeah. I did that, but I wasn't sure if we could or fix I was doing it right. I don't know. I don't know. I mean, and again, this is sort of like a bonus question, right? That's what extensions mean. It means it's a little bit more, trouble. What's curious to me, what I'm curious about, let me see. There might be a trick to this, but I'm not going to sit here and take up a lot of time for this problem. If this is the only problem you had trouble with, then you're fantastic, right? I'm curious about this problem, but I want to sit down and try it on my own and not try to do it right here live because we got too much to go through. All right. I mean, this looks like it might go somewhere. If you've done this and it doesn't look like it's going anywhere, try to do the tangent one instead. See if it goes somewhere, or start with this side and try some funky things. That would be really funky. That's what I'm thinking about right now. Anyway, I'm not gonna. All right, that's enough. There's two main things you can try to do. It's either this thing that sounds like you already tried, or it's go back to the tangent ones and see if they go anywhere more directly. I feel like the tangent ones might be a good thing to try. All right, I'm going to clear all that. Bam. All right, did I miss anybody else? Is that everybody? Okay, all right. So here's what we did. Here's the last thing we did last time. And it's going to lead into section 10.1. Oh, I want to keep that. Uh-oh. All right, Chad. It's going to be all right. All right. Okay. So what we did last time is we showed.
Can you fix the camera?
Oh, so yeah. So I always forget about that. Got to use some of my TA funds for a camera person.
Thank you.
Certainly. So what we did last time, I'm not going to redo it. You can watch the old video if you weren't here. We showed that the area of this triangle is 1/2 AB sine C. But it also equals 1/2 BC sine A for the exact same reasons. But it also equals 1/2 AC sine B for the exact same reasons. And then, let me take him out of the way, get out of there. I can divide each piece by 1/2 ABC. And what do I get? I get sine C over C. Oops, got it. I'll get sine A over A, and I'll get sine B over B. So basically, sine of an angle, the ratio of the sine of an angle with its side across from it is constant for any triangle. Which if you think about it, if this opens up more, this gets longer or has the opportunity to get longer. Does that make sense? So that ratio should kind of be fixed in a sense. All right, let me stop for a minute. So, because last time we did the area of a triangle based on angle and sides. This is the law of sines. All right, so let's do two things. Let's try one concrete problem, and then we'll try to do one not so concrete problem. Let's see what I mean. So this is a big thing, huge thing, monstrous thing. All right. And notice, what kind of triangle is this? Is it a right triangle? No. So this works for any triangle. It doesn't have to be a right triangle. Why would I expect trig functions to show up for non-right triangles?
because I can always create right triangles using its sides. That's how we developed this formula. All right. So let's try, let's do this. Let's see, Jeff, what do we got? Who remembers? All right, let's see if you guys remember a deep cut here. If this is 1, what would this side be?
One and a half.
Yeah. And then this side would be rad 3 over 2. All right. And I don't know if you guys remember, this is before we knew any trig of anything. And this is how I figured out that sine of 30 is 1/2, cosine of 30 is 3 square root of 3 over 2. Whoop-de-dee, whoop-de-doo, right? So let's try this. So supposedly, sine of 30 degrees over 1/2 has to equal sine of 60 degrees over rad 3 over 2, has to equal sine of 90 degrees over 1. And of course, this is kind of silly. Sine of 30 is 1/2, so that's 1. Sine of 60 is rad 3 over 2, so that's 1. And sine of 90 is 1, so that's 1. Check. All right, that was less than exciting. I agree. But that's just kind of a concrete thing, that triangle that we know is true. All right, let's try one that's a little more interesting. All right. So here's comes a triangle. My instructions would be something like solve the triangle. And that is some very vague ass sounding instructions. But what that means is find all the unknown sides and the unknown angles. So here's, if I give you this dude here, let me say that's 5, that's 17, and that's 93. And we'll say we'll just call it AB, and that'll be angle A. What's the easiest thing to find that you don't know currently?
A.
Yeah, it's crazy. What's angle A going to be? Does that help?
180 minus 93 plus 17. Whatever
Yes.
that magical number is.
Yes, it's the magical number 70.
Thank you.
Anytime. Now, here's a key thing. I cannot use law of sines for every solve the triangle problem, which is one reason why there's a law of cosines. Whatever law of sines cannot handle, law of cosines can, and vice versa. They're such a nice, they complement each other. All right. By the way, I might as well identify, so don't worry, I'll bring that back. But isn't this angle, side, does that sound familiar to anybody? Angle, side, or side, angle, whichever way you look at it. Does that sound familiar to anybody? Nobody. Or have you all? It does sound familiar. Remember those beautiful geometric proofs? Did you have to go through those geometric proofs? Don't worry, they're not coming back. You don't even have to remember this shit, to be honest. But I will bring it up just because the book uses a lot, and it's not a bad way to remember some stuff. So I will bring it up, but it's not necessary. So let me bring back this. Can I make a complete ratio? Meaning, do I know everything for one of these three statements? So this must be B, and this must be C. Is everybody with me? Can I make a complete ratio?
The sine of C over C.
Yeah, this guy's complete, meaning I should be able to use this. So if I could not figure out a complete one of any of these, I couldn't use law of sines, which means I have to use law of cosines, which we haven't learned yet. So, all right. So what's this ratio going to be? It would be sine of 17 over 5. And now I can set it equal to one thing at a time. What would I set it equal to figure out B, for example?
Sine 93 degrees over B.
Yeah. You can do cross multiplication, whatever the shit. You could also, do this way, to be honest. Obviously, it should work this way too, but it doesn't matter. You cross multiply, do some shit. Figure out what B is. Oh, wait. Make sure you're in degrees. Bum, bum, bum. Anybody? Nobody?
I got 17.078.
Yeah, I like it. And then to figure out this guy, can I use Pythagorean Theorem to figure out the last side?
I thought that only works on right angles.
Beautiful, exactly. That's why I'm asking.
Oh, okay.
Because I always get somebody that does that, and I'm like, well, no, the whole point is this is not a right triangle, so I can't use that. But I can use this again, and this time I'll do sine of 70 over A. Do you guys get the feel for how this works? Do you guys understand what I mean by if you can complete a ratio, you can use law of sines? Obviously, if you don't have enough information to complete one of these ratios, it's useless. You have too many unknowns then. Maybe. All right. Something's happening with a puppy dog. I don't know. So what do you guys
I'm
get
sorry.
for
He's
that?
making pig noises. It's really funny.
So what do you guys get for this here? Everybody try it.
$16.07.
Yeah, that sounds right. 70 degrees over. So this goes up, this goes down, and this goes up. So yeah, so you should get 16.07, is that right? Yeah. So this will obviously be much bigger than this because its mouth opens much more. Does that make sense? I always have that scene in Return of the Jedi when he sticks the stick in the Rancor's mouth. You got to get the right side. So the mouth is big enough you can stick a big old stick in there, but then this is a little tiny stick because it's a little tiny mouth. And this mouth is in between those two mouths, so its side is in between those two sides. All right. You guys semi with me at all? A little bit? Okay. All right. Sorry if you hate Star Wars. I'll come up with a different, or, just get over it. All right. So, all right. That is the basic idea of law of sines. They will give you a triangle with several things unknown. And once we learn both sines and cosines laws, the main way to tell not to do sines is if you cannot complete a ratio. Then you can't do this shit if you got too many things you don't know. Here is, now somebody remind me about something. This one was nice because I knew all the angles basically, right? Can somebody, all right, let's do this. Somebody remind me what sucks about solving for an angle with sine. Like if I wanted to solve this, there. How would you solve that equation? What would you do to both sides?
Take the inverse sine.
Take the inverse sine. I love it. What is the problem with inverse sines range? Like, somebody do this for me. What do you get when you do this? I'm curious now. Anybody?
Hang on. 19.47.
19.47. Okay. You sure that's the right answer?
That's what the calculator said.
So what? So that answer is where? That answer is in the first quadrant. Couldn't the answer be over here instead?
No.
Of course it could. Why not? Not there. Yes, there. What am I talking about?
Okay.
Isn't it possible for sine to be 1/3 here? Of course it is. Isn't sine positive in quadrant 1 and quadrant 2?
Yeah.
Remember, the output to an inverse trig is a reference angle. You guys remember that? It's a reference angle because it cannot access all the possibilities. What's the biggest that an angle can be in a triangle? I love this question. What's the biggest that an angle can be in the triangle? This is such a kick-ass question. You guys can do it. You can do it.
Just below 180.
I love it. Yes, just below 180. You can have a triangle like this. Right? Where this thing is 179.9999999, and this is half of the leftovers. But that's a funky ass triangle. So I can obviously have the output to inverse sine. Good Lord, Jeff. The range is going to be -pi/2 to pi/2. Does it access all the possible angles that a triangle can have? No, it can have above 90. So if this was an angle in a triangle, it could either be 19.47 or it could be, what's the other one? What's the other possibility? So it could be 19.47 or it could be, if the reference angle is 19.47, what's the angle that we're talking about?
(160.53).
Yes, you just take 180 minus the reference angle. So that would be 160.53. I like it. Couldn't both of those exist in a triangle? Yes, of course. Yes. Okay. Now, so that's one thing to realize, that there's going to be something that sucks about law of sines for certain triangles. Here's the kind of triangle. This is why it's kind of nice to know. So we just did one with angle, angle, side, or side, angle, angle, depending on the way you want to look at it. I love this. I love this. The one that doesn't work nice. The one that actually has two possible triangle answers is the angle side side. And that is just perfect. It is the ass. It is the jackass problem that has two possible solutions. Now, how physically, stay with me now, how physically could we have two possible solutions? So if I was given an angle and then a side and a side, so it has to be specifically an angle and then a side and then a side, like that. Because if I was given this, that would be side, angle, side specifically. That's not what we're talking about. We're talking about angle, side, side. Or side, side, angle, but it's not as interesting. Are you guys sort of with me now? All right, I want to use the other side of my board. Here we go. Because I've got something set up here. Ooh, that took less than a few seconds, Jeff. Shut up. So here I've got I don't want to say it. Oh, I'm given this angle. Let's say this angle is 35 degrees. I'm given this side is 8. And then I'm given, let me see if this makes sense. Sure. And I'm given this side, right? You guys with me? This side is 6. So at 35, and why do I make this dotted? Because this side, I don't know how long it is. Is everybody with me? They just gave me an angle, a side, and then another side. So how could this be? Could this be like this? Could it be a right triangle? Obviously not. This doesn't work. Because then it won't be this angle here. It would have to kind of go down this way and it won't be 35 degrees. Does everybody see what the idea is? So how would it work? Well, it's got to fit. It could be like this. Are you guys able to see that? Or am I going to have to figure out a way to do this? Right? It could be like this. Are you guys with me? Or no? Is anybody not with me?
We're with you.
I'm going to have to assume that for everybody. Okay, here we go. So it could either be this, or if I swing it through, it could be like that. What's true about the angle down here if it's this? Is this a big angle here?
Yes.
Hell yeah. What's true about it if it's over there?
It's small.
No, smaller, right? But this angle gets bigger or smaller. So the information they gave me to construct a triangle, which is like, I'm so happy I had this thing. To construct a triangle, I can do this triangle or that triangle. That'll work. They'll both match what information they gave me. Do you guys physically see the idea? Okay, I like it. All right, just to prove that it's hollow up there. So let's just do the work and see what happens. So let's draw it like this at first. Well, I might as well draw both possibilities, or it could be like this, right? Let's just work with one possibility at the moment. Okay. So let's call this, it doesn't really matter what you call these angles. Let me call this A, B, C. That makes this C, that makes this A, and then this will be side B. Can you go ahead and set up the ratio? Let's see, what angle can we figure out? Can we make a complete ratio? Am I insane? Can we make a complete ratio?
Yes.
Yes. So you can do, for example, you can, well, not for example, the only one you can do is the A's, right? So you can say sine 35 over 6. All right. And what's the only thing I can really set that equal to get anywhere?
C.
Equals sine C over 8.
Yeah, I have to use the C's because I don't know shit about the B's. Too many unknowns. Where do you go? Sine C over 8. I like it. All right, solve that for C. Let's see what we get. Make sure you're in degrees. I don't want radians to fudge us up. There it is. Keep this PG-13. Oh, I'm curious. Have I done this yet? I don't think I did this problem. Let's find out what this is. Did Jeff make a problem that works? Or did I steal it from somewhere? I think I stole it from somewhere. Wow. That's tiny. Well, that might make sense. What do you guys? Oh, duh,
I
Jeff.
got 0.76.
Yeah, so you're not done yet, right? So that's sine C equals 0.764, blah, 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 right? So what's angle C? That's where you have to do the inverse side of that.
I got 49.8864.
I like it. So we'll go that far. Okay. Now here's what you have. Oh, you guys are going to love this shit. Whenever you have the ass situation, which is not a phrase you ever thought you would hear in pre-calculus. Whenever you have the ass situation, you must check to see if this angle could be a reference angle. So I'm gonna finish the workout here, but over here I'm gonna say, what could C be instead? Well, what would the angle C be for the reference angle for this, like we did earlier? Here's 49. What would this angle be? You can't even see that, but that's angle C, right? This is 49.886. What is this? Come on.
130.114.
All right, so we're gonna have to, so we have two triangles to solve now, possibly. This might not work. Well, real quick, we can tell right now if it's gonna work, to be honest. A is 35. Is there room for B to have a value? There it is. So if C was 130.114 and A is 35, is there anything left over for B to have? Does that make sense what I'm saying?
Yes. And yes, it
If
does.
these two add to more than 180, this triangle does not exist. I can forget about it. But unfortunately, these two add up to be 165.114. So this can be 14.886, I think. Is that right? I think so. Let me stop. If I lost you earlier, you should have stopped me earlier. But is anyone lost at the moment with the idea? There were physically, I just showed you a minute ago, two possible triangles. That's what this is showing me. I knew this would work because we saw earlier there were physically two possible triangles. Why won't this work sometimes? Because this side might be too long and it just doesn't make a triangle over or something. There are times when that will not work in two different ways. All right, so we'll worry about that in a minute. Let's finish this one out.
Okay.
So now we know C is 49.886. So we're actually in this situation. Do you see that? Because now it's less than 90 degrees, right? And then this one will relate to this one because this is where C is big. All right. So I got 35. I got 49.866. Can somebody tell me what this angle is for this triangle?
I
35.
got 95.114.
All right. 95.114 sounds about right. Yeah. And now now what do I not know still? I don't know side B, right? And I don't know, I do know side A, that's right. So the only thing I don't know right now is side B. All right, let me stop. There's a lot going on up here. All right, so we did this. We got the answer for C and we went, oh shit, there's another possibility. I'm gonna worry about that in a minute, right? The angle for B, we got because we knew C and we knew A. So of course we know angle B. The only side I still don't know now, I know these two. I don't know this side. So I can set up sine of B to B equals sine of A to A.
I have a question.
Yes.
So the value you got for C, the 49.886, the reason you also got the 130 is because it could be a reference angle? Okay.
Totally, of course, definitely. Which is one advantage law of cosines has, because the inverse cosines range is 0 to 180, which covers all of the possible angles a triangle can have. So inverse cosine is much nicer, which is interesting. It still works. Cosine's an asshole, so inverse cosine is nice. I like that. It still works. Okay, maybe. So then if you solve this for B, that triangle is complete. I'll have A is 6, C is B. C is B, Jeff. Good job. C is 8. B I'm going to figure out right now, and I know all the angles because I knew at the beginning A was 35. So that's a completely solved triangle once I figure out what B is. Does anyone have what B is?
I don't think I did it right, but I got 10.419.
Let's see. Oh, shit, Jeff. Yeah, you got it. So now that is a completely solved triangle because I have A, C, and B sides, and I have A, C, and B angles. So now we got to figure out this triangle. So what I would highly recommend is you draw one triangle and then you redraw it later. Don't try to do it all in one triangle. But I only have so much room up here. So let's reset. So this triangle is there. So let's focus on this piece. In fact, I'll just kind of delete that a little bit. So I got this triangle here. So I know A is 6. I know C is B. C is B. Why do I keep saying that? C is 8. I know angle C. We figured that out to be 130.114. And angle B, we figured out to be 14.886, which is making sense visually. So all we don't know is side B, just like over there. So now I can set up my sine 35 degrees to 6 equals sine of 14.886 to B. So it's always sine of the angle ratio with the side equals sine of the angle ratio with the side. I could use this one, but notice how I always try to go back and use the stuff that I totally knew at the beginning. Just because, just in case I made a mistake in the middle somewhere. And then if you solve this for B, what's that going to be, Jeff? I don't know. All right, I get 2.69, which makes sense visually. Let me know if that's, you get something different. All right. Maybe. So law of sines is its own deal, right? It's definitely its own deal because it deals with, sorry to use the word deal so much. It has to do with non-right triangles. We built the law of sines by creating a right triangle inside of another triangle, of course, because that's the only way to get trig to come into play. But once we have that, we can use the results for non-right triangles because the whole thing was not a right triangle, just like this weird ass dude here. All right, maybe. Want to try another one out?
Yes, please.
Guys? Okay, let me take one right out of the book. Oh, by the way,
my dog, I'll be
yeah. Let me see if you guys get this. There is a way for this to have no solution. And, well, there's a way for this situation to have no solution. All right, let me see if you guys are with me. How could I make it, so let's say that all right, everybody has all of this, right? I'm going to start to erase some of this. Does anybody need any of this still? No? Okay. All right, let me see here. Let me leave some of this in here. Yeah, we leave you there. Okay. So this side, when it's 6, I get these two answers. Can somebody figure out how is it that I could get one answer for this setup would be if this was perfectly straight up and down. Then it couldn't be 6. Are you guys with me? If it was 6, it would go past this a little bit. If it was perfectly straight up and down, this would be a right triangle then, right? Stay with me, stay with me. Or come with me. Get up here with me. All right. How long would this side be then? Now this is old school trig because now we got a right triangle. And I know that's 8 and I know this is 35 degrees. How long would this side be? What would you do to figure out how long that side is? What trig function relates this side, this angle, and this side?
Sine.
Sine, I like it. So 8 times sine of 35. What's that real quick? 8 times sine of 35.
4.59.
Okay, sounds about right. If this was 4.59 blah exactly, this would make a right triangle. If it's any shorter than this, so if the last side was 4, that means no triangle can exist. It can't reach this line. This angle is set, this length is set. If this is too short, if it's shorter than 8 times sine of 35, it is never going to reach that other side. I don't care how much I swing it, there's no way for it to reach that side. Do you see that? So there's a possibility of 2 answers. There's a possibility of 1 answer. And there's a possibility of no answers. Nope. Okay. All right. And the book's got pictures of this too. If you want to see like computer generated pictures, that would probably look a little bit better than mine. All right. So let's try another problem out from the book here. Let's see. Oh, let me show you what it looks like in the book. Here we go. Perfect. So just like I told you, solve each triangle. Right, so I don't know, let's just try the first one. Look at the angle that they give me in the first one. Actually, just look at the first one. This is kind of silly. See the angle they give me, that alpha is 119. All right, let's try to draw this. So they give me that angle A is 119 degrees.
You're still on the screen. You're still sharing.
I'm sorry. Oh, okay. Somebody got that? Go ahead and write that down.
Got it.
This is what I hate about this, is I can't show both. Oh, not easy. Oh shit, now I gotta know what I'm talking about. Okay. And somehow side A is 14, and somehow side B is longer than side A. Is that gonna happen?
No.
No.
Let's try to solve it. Let's try to solve it. So if I do sine of 119 over 14, is that cool? Sine of 119 over 14 equals sine of B over 26. Is everybody cool with that? Sine of the angle over the side across, sine of the angle over the side across. So get sine of B equals sine of 119 times 26 over 14. And what I normally do is I do this, inverse sine, and I just put all this shit into it. But what's interesting to me is just do this piece by itself right here. I just want to show you what I normally do, but try to do this. What is sine of 119 times 26 divided by 14? Marker all over.
0.0024.
No, what happened? Sine of 119. Oh, did you do inverse sine? I don't know what you, no, then you would have gotten an error. Sine of 119 times 26 divided by 14.
I got 1.624.
And what's wrong with that? Is there an angle for which sine is this? What's the biggest sine can be?
It can't be greater than 1, right?
There you go. Can't be greater than 1. There's no triangle that works. That answer is no solution. Next. And we knew that before we did any work, right? Hopefully you guys got the point. The largest angle had the not largest side across from it. That doesn't make sense. It can't happen. The wider your mouth, the bigger the stick fits in there. That's going to be a good clip for my dean to see for my evaluation. Jeff, you were talking about putting sticks in your students' mouth? No, Dean. I'm sorry. So let's try 16. I'll put it up here on the board. $16, what time we got? Okay. 16 says B is 3.5. C is 5.3. And they like gamma for some. Gamma is 80 degrees. So alpha, beta, gamma go with side A, side B, side C, right? So B is, I'm sorry, C's angle is 80. So it's almost 90. So we'll do, you could do it, Jeff. So we'll say this is gamma. And then across from that is 5.3 degrees. Not degrees, Jeff, you could do it. There you go. Angle B, and then there's 3.5, and then angle A, I guess we'll call it alpha. Call that beta. All right.
How did you know that side C went with gamma?
So again, it's because Greek letter alpha is A, Greek letter beta is B, Greek letter gamma is C. So if you see gamma, you could actually put big ass C there instead. That's fine. And use A, B, and C instead of alpha, beta, gamma. Is that all right?
Yeah.
And to be
like
honest,
the people were covering it, so I couldn't even see that.
right here, they tell you gamma is opposite side C. Okay. Is everybody with me? So they gave me this. I tried to draw my angle roughly a little bit less than 90, right? And then the other stuff doesn't really matter that much. So what can I set up to do this? Let me tell you this. Try to figure out angle beta. Set up the appropriate, make this a little bit bigger. Set up the appropriate ratios to figure out angle beta. Beta. So obviously you can make a complete ratio there. So that means this will work. .5. Does everybody see that? So I multiply by 3.5, and then I would take inverse sine of that. So that goes up and goes in there. And that's a nice way to get there quickly. And then throw all that shit in the calculator at one time. Yeah. What do you guys get out there?
$40.57.
Yep. Now think about it for a minute. If that was a reference angle, the other possibility would be what? I call beta 1, beta 2. That's what I forgot earlier. You can call it all beta 1 and beta 2 and all kind of stuff. What do you always do? You always do 180 minus this, right? Could that possibly be? Does that angle make sense in this triangle? No, why not? Because 80 and that is bigger than 180. There's no way. So there is no second triangle. Yay! So then I can figure this, I can just finish this one. I've got beta. What I'm missing now is alpha and A. How do I get alpha? I know this is 40.57 degrees. So of course now I can get alpha, right?
Yes. Which would be 59.43.
Yes. And now I can set up sine 80 to 5.3 equals sine of this business. It's a little a dude. And once I solve that for A, I've got everything. I've got all the sides and all the angles. Oh, wait. So I get 4.63 there. See if this makes sense. Which angle is the biggest mouth? This one. And that's the biggest side. What's the middle mouth? This one. And that's the middle side. What's the smallest mouth? That one. And that's the smallest side. Maybe? Okay, so at least it makes sense in that respect. All right, so here's the last thing for tonight. We're probably going to do more of these. But I want to prove law of cosines to you real quick. It's actually a really nice, quick thing. It's almost too nice to believe. We'll see if you agree. All right. So let's say I give you this triangle here. Yeah, okay. And I'll say this whole thing here is B. Can somebody figure out, based on what I've given you, can somebody figure out what this side, what this dotted line length is? It's hard to make a capital C. Anybody? This is basic trigonometry.
Isn't
What's
it
the
A
length of
times
this
sine
side?
C?
Say it again, sorry.
A times sine C.
Yes. So the y piece is the hypotenuse times the percentage of that lies in the dirt. So it's sine C. A times sine C. So what's this side going to be? This up to here.
A times cosine C.
That's crazy. A times cosine C. So what's this? Notice I didn't tell you that angle, but I don't care. What's the expression for this based on anything I told you or that we figured out? What's this whole thing? B. What's this piece? A cosine C. So what's this piece?
A cosine C minus B. B minus A cosine C.
Yeah, because B is bigger. Now, this is a right triangle here, right? Please write the Pythagorean theorem for that, please, now, based on what sides it has. This triangle right here. What's the Pythagorean theorem look like? What's the Pythagorean theorem look like for it? All right, so now watch, this is kind of cool. So this will be a squared sine squared c plus, I'm going to FOIL this out, write it twice. I'm not going to do it, actually, I'm not going to write it twice. B squared minus AB cosine C minus AB, so minus 2 AB cosine C's. Is everybody with me? Just foiling it out if I wrote it twice. Plus, right, this thing times itself, so A squared cosine squared. Anybody notice something really nice? Most basic trig identity. No? No.
Wouldn't sine squared c plus cosine squared c be 1, so just a squared?
It would be a squared, yes. A squared sine squared plus a squared cosine squared is a squared times 1 is a squared. Plus b squared minus 2ab cosine c equals c squared. So let me write this better up here. What we just figured out is a squared plus b squared minus 2ab cosine c equals c squared. So if c is not a right angle, this is like a correction to the Pythagorean theorem. If c was a right angle, what is cosine of 90? What's cosine of 90 degrees?
1.
No.
0.
0. So if C is 90, this is a right triangle. So then you get Pythagorean theorem, don't you? See that? So this is an adjustment. If I don't have a right triangle, it adjusts based on what C is. This little term here is the only thing that wasn't in Pythagorean theorem. So Pythagorean theorem is actually a specific instance of this. It's if C is 90, then you get Pythagorean theorem, but this is the more general idea. That's the law of cosines. And I could do the exact same thing if I rotate this. Sorry, did I miss somebody? Or am I just hearing things? I'm probably just hearing things. I could write this as b squared plus c squared minus 2bc cosine a equals a squared. Do you guys see the important parts? Important parts? So AB, missing one. Or it could be a squared plus c squared minus 2ac cosine b equals b squared. Because it doesn't matter. I could have redone the whole damn thing by rotating this sucker around. I don't know if you guys, maybe not. So if you look at your green sheet and look at your law of cosines, it'll have those 3 options. That is basically the adjustment for a non-right triangle. It is such a cool thing And I hope I did it justice, because the first time I saw that, I was blown away. It's so freaking cool. If it's not a right triangle, then you got a little adjustment. No big deal. That's awesome. I'm going to assume that you're all going, wow, and you're all muted, so I can't hear you. All right. All right. That's enough for today. So tomorrow we'll do some more examples of sines and cosines, and I'll show you how to tell when to do which. It's really nice because, like I said, whenever one doesn't work, the other one will work if it's doable. Some triangles are not solvable. We saw that. So let me know if you need to hang out, ask some questions. Otherwise, you are free to go or log out.
Thank you.
You're welcome.
Thank you.
Thank you.
Anytime. All right, guys. I'm going to head out. I don't see any questions. Bye, everybody.